Acid chloride, right? So that's another compound that we can make from carboxylic acids. For example, if we take a look at some sort of carboxylic acid, such as maybe like this one, right? So let's take the propanoic acid, CH3, CH2COOH, as an example, right? So it turns out if it reacts with the so-called thionyl chloride, SOCl2, it will be able to form the acid chloride, right? So what is the acid chloride? So basically, what's going to happen is that we are going to remove the OH group again, right, and switch it to a Cl, chlorine atom in this case, right? So 1, 2, carbonyl, and Cl. That's it. That's your acid chloride. So plus side products will be formed, such as HCl and then SO2 as a result of this reaction. Acid chlorides are useful materials because they can be used to as alternative substrates to make esters again, right? So let's take a look at some example, right? So maybe we'll take our acid chloride, which is looking like so, acid chloride, and then we're going to react it with some sort of alcohol, right? Let's react it with our favorite isopropanol, right? So like OH bond here and your isopropyl, right? So you are going to circle Cl and circle H. Guess what? They will be removed as a result of this reaction, and liberated electrons on the carbon and oxygen will connect to make a covalent bond, which will make the ester group as a result. So basically, you are going to make your HCl, right? And you are also going to make another compound, which is going to be the ester, right? So that's going to be our pretty much like most coveted compound, right? So here, electron on the oxygen from the isopropanol, CH, CH3, CH2, right? And then you're going to form that. So this is going to be your ester again, right? So you made the ester, so you did the synthesis from the acid chloride and alcohol, you produced your ester, right? So that's an alternative route, if you will. So then another way, so to make esters is going to be our pretty much third way to do that. Is going to be take a look at some anhydrides, right? So which have a very peculiar structure, basically. So which is looking like this, right? So we have here a couple carbonyl groups which are joined with a oxygen with an oxygen atom, right? So, and then let's say this is going to be our ester, like this, not ester, but the, what's it called? Anhydride, right? So that's that. So that's going to be our anhydride group. So this is going to be our anhydride functional group, right? That's what it looks like, COOCO. And it's attached to some sort of alkyl chains, right? Two isopropyls, maybe it's going to be ethyl and methyl, so the opportunities are infinite, pretty much. So now we're going to react this with an alcohol. Let's just use potentially, uh, for example, ethanol, right? So OH here, and we have here our CH2 and CH3, right? So now what you're going to do is that you will circle kind of, so you're going to remove one circle, right? You are going to circle what's going to be making a side product, right? So this guy and that guy will be connected. So guess what they're going to make? So they're going to make an acid, right? So an acid will be produced. So as a result of this reaction, one. And the ester will be produced. So let's take a look at this electron and that electron, which are connected in the uncircled parts, right? And then you're going to make your ester. So carbonyl, boom. Then we have electron, oxygen, and that's it, right? So this is going to be our ester compound right here. So the ester is made, the acid is made as a result of this reaction between the anhydride and the alcohol molecule. So next is the hydrolysis of esters, right? So there are two ways to hydrolyze an ester to kind of like come back to its components from which it was made, right? So let's take a look at some ester example, right? So maybe we are going to have like benzoic acid ester, right? So which we're trying to hydrolyze. So hydrolysis means use water as a cutting agent, so to speak, right? That cuts bonds and makes simpler compounds from what used to be a relatively complicated compound, right? So maybe like this one, right? So CH2, CH3, right? So how do we hydrolyze this ester? That is the question, right? So basically what you need to do is like say, okay, well, HOH will be one of our essential reagents, right? So we're going to remove or going to circle, right? First, what we're going to remove. This part, ethyl with oxygen and H, right? If they're connected and make the OH bond, right? That's the only possibility here. You are going to obtain your alcohol, right? If you connect, let's say, these squiggly parts, right? So, and then this squiggly part, you are going to make, guess what, an acid, right? In both cases, there is only like one point of connection that's going to be possible, right? So hydrolysis happens. So it's basically the reverse of the esterification, and we're going to show our products. Let's start with an alcohol, right? So we're going to form this like H, right? Dot, oxygen dot, H dot, oxygen dot. Dots are connected, and then you're going to form the bond, right? So of course, don't forget your parts which are not touched. They are still there, right? So they need to be kind of like carried from side to side of the chemical reaction. And then you're going to use your, show your acid, right? Here and there. So basically this is going to be the benzoic acid that will be formed, by the way. So here, this one, that, and then we have OH, right? And then the dot here, right? So that's your one only point of connection. So that's it. So you have your benzoic acid and you have your ethanol as a result of this specific kind of like acid-assisted hydrolysis of an ester, right? So then there is another one, another way to use kind of like the hydrolysis in a very similar fashion. So let's start with the same substrate, except we are going to use now the base-assisted hydrolysis. So we're going to make some edits here. So we'll just remove this, and then instead of HOH, we're going to have sodium OH, right? So we're going to have sodium OH. So sodium hydroxide. So let's show that. Sodium hydroxide is a base, right? So now, what are the products? Well, turns out you will have the following things, right? So let's see what we're going to kind of like show here, right? So here we go. It's going to be a little bit different circling in this case, right? So we are going to form the salt of the respective carboxylic acid, and we're going to form the alcohol, right? So yeah, basically what you're going to connect here, just for our breakage of the bonds and making of the bond purposes, so you are going to circle this, right? Electron, circle it like in a fat fashion, and then this guy, right? So they will be making the acid. Sorry, rewind, right? So I'm going to circle this guy, right? So now, what do I mean by this? So finally, the moment of truth, right? So here we go. So we are going to connect these circled parts, and then we're going to show the acid, right? Basically, the acid of the benzoic acid will be formed, also known as sodium benzoate, right? So sodium benzoate. So this part, C6H5COO and sodium. That's it. That's your connection. Technically, there is a negative charge and positive charge, right? So now the leftover pieces will be this one, squiggly one, right? And this guy, OH. So now what's going to happen is that you are going to connect CH2 with a dot and then O technically with the dot as well, right? So here we go, O with the dot, and then we have to have, so CH2 with the dot, okay? And then OH with the dot. So let's put them next to one another, those dots. Here we go. Finally, we got our alcohol back and our salt, right? It's almost like the initial substrate that we would use to make an ester, right? So except we don't have an alcohol and acid, we have the alcohol and the salt of the acid, right? But it's kind of like close, right? So almost to the like classical um, esterification substrates, right? Acid and alcohol that you use to make an ester. So here we go. That's your like not acid, sorry, base assisted hydrolysis, right? So we hydrolyze, we cut this bond in the ester, right? And then we kind of like make simpler compounds, the essentially constituents which were like used to make an ester in the first place, right? So the acid in the salt form, however, and the alcohol.